lost one of our, we're going to be recorded now. So this is, I guess what I'm going to go ahead and call this is the Hacker Within 2.0, which has a much less subversive name of Coding Club. I'm just reading some of these things. Okay, well, you don't have to actually have knowledge to talk about what you hate, guys. I mean, that's the whole point of the what do you hate question, right? It's supposed to be a hot take. So feel free to revise if you want to veer into metaphor. That's fine too. Okay, so here we are in Hacker Within 2.0. Now, what exactly do we do here? What's the point of this? I think we're going to have a few talks today where we kind of drill into that a bit deeper. Now, I've got a couple of Fortran. Thanks, Dagmar. I knew that was going to be coming in here somewhere. I see some MATLAB too. God bless you all. So here's the slides. If, like me, you're a bit ADD and you want to do it at your own pace, you don't want somebody controlling what you're looking at, you can do that. I'm going to go ahead and share so you can see me. Can you see those slides, folks?
Yes.
All right. Thank you.
Yes.
And thank you for the human voices. That's always heartwarming. So here we are, Coding Club. Now I'm going to give you my welcome and sort of tell you what I think it is. And then some of my colleagues are going to jump in and probably tell you something totally different and possibly contradictory. But that's part of the point of hacking, right? So here's me. I'm Jeremy, by the way. I'm based in theology and religion. I guess I'm a theologian who was a bit of a geek. I'm not sure which.
I sent you now.
We are getting some relatively unrelated conversations. So if you're chatting with someone in the room next door, maybe mute yourself. Anyway, I'm based in theology and religion. I do mostly R these days, but I used to do lots of other things. Now, I think I've already mentioned that what we're doing now is sort of Hacker Within 2.0, or at least that's kind of how I'm thinking of it. What do we do here? Well, at least what we've been doing is hacking code, lots of open source. And the thing that I want to talk about today is one of the aspects of this gathering, which is perhaps been the most hidden, which is hacking culture. Now, this is, of course, this is my own personal take, and some people might want to provide their own disagreement or nuance, and we'll have Q&A at the end where we can kind of jump into the fray on that. But okay, some of you might be saying, okay, Kidwell, I'm curious, what is hacking culture? Now, let me tell you what I think it is. But before I get into that, I have a question for everyone now that I think we've almost finished talking about breakfast cereals. If you haven't gotten into that, do feel free to. But quick question for anyone who wants to put it in the chat. What do you need to code well? That is, what are the physical and spiritual things which you need to do your hacking? Just curious what folks are thinking out there. So we'll just pause for a minute and watch that scroll by. Oh, Kat, you hate JavaScript the most. I'm so sorry. Okay, so patience. Yes, magic. Stack Overflow so much. Yeah, versions, playlists, practice, knowledge. Yes, logic. Okay, that's optimistic. I like that. Emacs. Okay, org mode too, maybe. There's a lot of good stuff in here. No one yet has said a computer. I guess we're just assuming because we're all cyborgs that it's sort of, implied, and the body extension. Control over my computing environment. Thanks, Warwick. Planning, some peace and quiet, fun. Yeah, okay. Patience, yes. Yes. Cat exclusion zone. I could not disagree more, but I appreciate you for saying it, Dagmar. Okay, so we're seeing some sort of things emerging out of there. Let me give you my 5. And again, I should have had cats for my 6th. I'm not being contentious enough here, but here's what I think. Hardware is the obvious one because you need to have a decent PC. And what could be worse than having a crappy laptop that won't run R or whatever? You need to have software, and that's why we all like open source so much, because we don't have to pay for it anymore. I think you need to have knowledge, and that popped up in the chat a lot. I think that's kind of what Stack Exchange is really in a lot of ways, isn't it? And so, that's kind of sorted for us as well, because you've got the internet and you've got open educational resources out there. And then it starts to get a little more complicated, right? I think, and I didn't see anybody saying that, oh yeah, work's got time there. So you need to have time. Another way of putting that is leisure. or you need to have the kind of space to be able to chase the stuff that you want to chase. And I think the last one, which is the kind of really the impetus for this gathering, is access to community. Stack Exchange works a little bit, but it has limits, right? You know, you kind of, we've all had that thing where you put a really great, well-formed question out there with reproducible examples, and no one ever answers it. And you're like, oh, dang it, I need real human beings somewhere. Okay, so those are the kinds of things that I think of when I think about, you know, doing the kind of hacker thing. And so what I think is interesting in terms of hacking culture is that, oh, and by the way, I don't mean social engineering. I'm sure some of you might have thought with excitement that we'd be engaging. I mean, maybe we could do some social engineering if you want to. We'll save that for offline. But it's not quite what I'm getting at here. I think a hacking culture, as I'm defining it, is, let's assume we've got the hardware and the software sorted, but getting access to time and getting access to community require a different kind of intervention. And basically what we need, you need the organizational culture to allow you to do the stuff that you're good at doing, right? You need to have a lack of people blocking you, or a proliferation of people supporting you. And so that's trickier. And I think that's what I mean when I'm talking about hacking culture here, which is a different kind of thing and maybe more of a long game, actually. Okay, so why on earth would we want to do that? Well, I think if you weren't already on board with me there, in terms of hearing that you might get some free time, I think there are maybe more pragmatic ways we can talk about this. And a part of this, I think, it can be helped if we talk about sort of what is open, I mean, we could slot in different terms here, open, hacking, kind of whatever you want to there, but there are lots of different ways of thinking about this stuff, not just as writing code, but just getting by in daily life, right? And so this is where the kind of theories of what is open access, what is open code, what's open research, and the ways that we talk about that can be very specific and technical, or rather broad and expansive. And I'm kind of pushing for the kind of broad, expansive definition, which we all kind of know it's there, but we don't talk about it very often or very explicitly in these contexts. Okay, so open can be about transferring knowledge. Open can be about, oh, thanks, Ashley, I just saw that, but it sounds like we're okay in terms of audio. Well, if it gets bad for everyone, just start throwing things at your screen and I'll see the visual. Okay, so what's open? It's not just about downloading information, right? Not just about transferring knowledge, but creating the possibilities for the production or construction of knowledge. And that's particularly apropos in terms of the modern university where we all find ourselves. Just sharing would be another way of putting it, but it's also kind of way of thinking about kind of how you kind of situate your thinking. And so it can be thought of as a cognitive trait. Now, the thing I want to emphasize is hacking culture might sound exotic and fringe, but actually it's something that we're all sort of doing all the time already. And there's some obvious things that we do that we don't necessarily kind of appreciate, like attribution. I mean, this is one of the things I love about doing stuff on GitHub is everyone automatically gets credit for their work. So there's a kind of meritocracy that's just kind of baked in to the idea of version control. But transparency is another aspect, I think, of culture hacking. That is being honest about the things that you suck at and don't know how to do, or maybe even talking about projects that you failed at so that others can learn from what you're doing and also can feel free to take risks in the kind of same kind of space. So it's not about pretending to be perfect, but it's about just being really visible about our failures and working towards the next thing together. I think also culture hacking is about just being creative and breaking stuff and just feeling okay about breaking stuff. Now, another thing I just want to emphasize in terms of thinking about kind of hacking culture, and as I'm making maybe an argument here for let's do this a bit more around Birmingham, there are different levels at which we do culture hacking, right? There's the kind of basic level where we're just talking about dumping your code in a repo, right? And then there's some more kind of intermediate levels. And this isn't just the case for writing code in kind of university research context. This also has to do with the way we do education and the ways that we do research. And in case you went to a talk I did last week where I was talking about all of the same stuff with research or with education, sorry for the overlaps. But just let me give you a couple of examples of how this looks, right? So kind of level one, we can think about open education, right? In terms of putting modules online for free. So you wrote a class or you wrote a textbook or you wrote some cool materials, you put that stuff up online, job done, right? But you can escalate the ways that you're doing open there, right? And that can be about taking the processes of evaluation and review and the generation of materials and putting that up and making that open for folks to see. And again, open is not just about access, but open is about showing failure, right? Because that's version control kind of shows all of the ugly details if you're doing regular commits. Level 3, I think, is when we start to think about organizational culture. And this is where I really want to raise these questions for us all to think about at Birmingham. In particular, for those of you who are on the call who are a part of the University of Birmingham, what is it about our culture as an organization and the culture of our teams and the ways that they link together, which makes it easy for us to be innovative, collaborative, and inclusive? And if we are those things, fantastic, let's replicate it more. And if it's not that, okay, we need to diagnose that and really think about kind of how we start to develop and build that up. And then at the very top of it is this kind of sector level, the national level, and that's about research culture, but it's about a whole lot of other things. So the main point here is if we think about open in particular ways, it's not just about doing the kind of basic level stuff, but it stacks up, and the stuff at the top level enables us to do the stuff at the bottom level in a way that's kind of free and enjoyable. All right, I'm gonna move along a little bit here, but I mean, the obvious reasons to do this kinds of stuff, I think it's more fun. It helps in terms of spreading around social justice and fame and fortune, of course. Now, I think there's a lot of interesting discussion for us, and I'd really like to invite us to start a conversation around the organization about open culture, open organization, and open management. And I think there's a lot of really interesting examples out there in different organizations. And one good example is Red Hat, who's done a lot of cool stuff around open, but they've been very public about it, right? So they've got a whole open values charter that's up in a GitHub repository, and it's not code. Well, it's the kind of code that they use for managing their teams, right? What would it look like if we started to do that kind of thing and invited that level of transparency and tried to kind of continually improve the way that we work together as an organization? I think there's a kind of cascading in terms of how that makes it a lot more fun to do things like the kind of everyday in terms of hacking. And of course, I think what this does at the very end of the day is it makes us happier and frankly healthier. And there's lots of evidence that within open organizations, you have better engagement with staff, better well-being, better performance, all of it. So there's the thing that we can tell the managers, I guess. Okay, so how do we do it here at Birmingham? I have absolutely no idea, but I'm very keen to have a conversation with people who are also interested in this. So if you're interested, zap me an email. We'll start to think about how we can get together and maybe start to build up this aspect of the way that we do code and hacking around Birmingham. I'll look forward to being in that conversation with you all. And that's us. That's me.
Thanks, Jeremy. Right.
I'm going to turn off sharing here, sorry. There we go. Stop.
Do we want to take any questions for Jeremy before I carry on to my talk, or shall I just plow on? Tell you what, if you've got any questions, stick them in the chat and we'll pick them up as we go. Okay, can you see my screen now?
Yes.
Cool. Okay, so this is what I'm going to talk about. This is why do it well. So coding, software engineering, however you want to call it, hacking, why do it well? Not just why do it, but why do it well? That's me. I run the research software group. Where's my button? We are part of Advanced Research Computing in IT services. So Steph and Aslam and various other people on the call are in Advanced Research Computing. The research software group in particular is 10 people who support people who use Bear compute services, so the supercomputer, virtual machines, and so on. We look after a lot of research software, research applications and libraries on those compute systems. We provide free advice, coaching, coding, and we work with researchers across campus through the whole range of researchers. And something we've been doing more in the last year is actually getting dug in and embedded in research groups for larger chunks of time working on funded collaborations. If you want to know more about what we do, that is a link to our annual report, which we just published for 2021. And that has loads of case studies and examples. It's like 48 pages or something. So if you're looking for a really exciting read, you may want to consider that. This is who I've written the talk for people who are researchers, which could be anyone doing a dissertation in their sort of undergraduate times, all the way through PhD students, postdocs, professors, anybody at all in the research community. But I really hope it's also useful for anybody else here who is interested in coding, software engineering, hacking, etc. This is a quote which I want to read out. I'm not going to read many quotes out, probably two, I think. We know that modern scientific research isn't possible without software. From short thrown together temporary scripts and the abundance of complex spreadsheets through to the huge software enterprises behind international efforts, such as the Large Hadron Collider and the Square Kilometre Array. And that's from the Software Sustainability Institute's very frequently quoted paper, the title of which I will talk a bit more about in a minute. And the second one, I'm not going to read all of this, but I'm going to read some of it. This one's from a UKRI report in 2019. Software lies at the heart of many research and innovation activities. It's needed to control instrumentation, ... modeling, etc. And then there's a famous, very frequently quoted statistic, which seemingly appears in every government paper about this topic, which is on line, I'm starting at line 6 near the end, in academia. 92% of UK researchers use research software and 69% report that it's fundamental to their research, with software development a research activity in its own right. The near ubiquity of software means it's not possible to disentangle the quality of the software from the quality of the research. Unreliable and untested software leads to unreliable results that cannot be trusted. So the UKRI are saying that kind of thing. And they're saying it a lot, and the Office for Science has published a paper last year saying very similar things. That final sentence, unreliable and untested software leads to unreliable results that cannot be trusted, is the negative version of the much happier slogan, really, of the Software Sustainability Institute: better software, better research. What is good coding? I'm pretty pragmatic, really, and I think good coding probably depends on what you're doing. If you're writing some scripts that you're going to run once and never run again, that's one thing. If you're writing a library that you're going to share with collaborators everywhere and they're all going to adopt, that's different. If you're writing something for a medical instrument or a manned space vehicle, well, that's probably another level of quality you would be looking for. You want the answer to be right in all of those cases. You don't want to write a script so quickly and have a 50-50 might be right, might be wrong. What's the point in that? You want it to be right, but you are willing to put more time and effort into certain circumstances, into certain different bits of software to ensure that they are right. This is what I'm going to do in the remaining time for my talk. I'm not going to answer these questions here. Simon will talk more about it, and he's probably editing his talk at the moment to answer these questions. These are just examples for you to think about. There may be loads more things for you to think about, and Simon will bring some up, and you will all have your own ideas. Why would you do testing? Why would you get other people to review your code? Why would you write documentation that's either for users or for developers, which might just include you, or it might be a team, or it might be other people the other side of the world who you never meet, who fork your repository on GitHub? Why would you publish and share your code? Why make it open? Why would you use automatic code checking, syntax checking, continuous integration, etc.? There are loads more questions I could have put on. Those were the first 5 I came up with. And Simon's going to talk about that. His talk is all about what do you need in your toolbox to do good software engineering. And I could now explain some of the benefits of doing good coding. And I probably would have done a couple of years ago because of the Software Sustainability Institute's thing, better software, better research. But I was sort of taken with the idea of unreliable software leads to unreliable results. So I'm going to show you a bunch of examples of where it's gone wrong as a way of inspiring you to to put the right amount of time into your own software engineering to try and make sure that it's right. This is a really nice picture from XKCD. If you don't follow XKCD comics, I really encourage you to. That is somebody's comedic idea of what the stack looks like for the internet, and some random project down at the bottom holding everything up. If you were following all of the Log4j stuff in the last few months, you might think that might be a good candidate for that little pillar there. Something that loads of people use that it turns out has a big problem. You really want to know you can trust all of that stack, but XKCD suggests you might not be able to. I'm going to give you a bunch of examples of what happens when software engineering in research goes wrong. These examples were taken from a friend of mine's talk, Mike Croucher, who currently works at MathWorks. He used to lead the research software group in Sheffield University. Mike is great. He's written many good talks. This one is particularly useful. I suggest if you like what I'm talking about, note down that link. We'll share these slides afterwards. Note down that link, go to it, have a look at his talk, and you'll be even more convinced than you are based on what I'm saying today. Right, first example, 2010, some very high-profile Harvard professors publish a paper which is used around the world to make the case for austerity cuts following the financial crisis a couple of years earlier. Loads of governments base their plan to do austerity on not only this paper, but to a certain partial extent, this paper. A little while later, a student called Thomas Herndon was given an exercise by his teacher to pick a paper, a famous economics paper, and try and replicate it. So he tried to do that. He couldn't replicate the results. He contacted the professors, said, I'm doing my homework, I'm trying to reproduce your results, I can't reproduce your results. They sent him their spreadsheet. He investigated it. He replied saying, you have not dragged the formula to the bottom of the column. And their results were wrong. And this is used as this is kind of the most frequently cited example I've seen of bad software practices in research. So these two Harvard professors who had a massive reputation for being brilliant economics professors now have a reputation for this, which is probably not what their plan was. Another Excel thing, this was a very famous one for years. Microsoft Excel has many useful features, which you can turn off. Most people don't know where the settings are for that or don't think they need to. If you put SEPT2, which is the code for the gene septin2, you put that in to Excel, it will magically alter it to September the 2nd. So instead of having a gene name in your spreadsheet, you've got a date, which is different type and stored as a different type of value. There are other ones as well. There's one that's March 1, and there are various other genes, and loads of papers, had erroneous results because Microsoft Excel was used to process the data and people didn't notice that it was magically changing what they were putting into it. Microsoft came out and said, of course, you can just turn off the setting. If you're using it for this purpose, you should switch off this setting. Their view was you should know that. In 2020, so last August, the genetics folk of the world, I'm afraid I don't know exactly who did this, but the people in charge of this renamed 27 human genes so that they would not have this effect in Microsoft Excel, which actually I think is a really good pragmatic thing to do, but very sad that they had to do it. I don't think it was Excel's fault. I don't think it was the genes people's fault. It was just a collision of two worlds where you have two different people using two different paradigms and they don't behave the same way. It's kind of interoperability problem. Is the conclusion you should never use Excel? I'm not going to answer these questions. Or is the conclusion that you should test and verify and validate and cross-check and share your spreadsheet and try and make sure that you've got the right answers when you're using Excel? I think we can just conclude the answer is not stick your stuff in Excel and trust the graphs it spits out at the end. This one, there was a famous research group led by a guy called Chang. They were contacted by some researchers from Switzerland who said, they published a paper in Nature, pretty high profile place to publish such a paper, basically saying your results are wrong. And they looked and they went and they explored their software and they found that it had a bug in it, which was inverting 2 columns. And so the answers they were getting were all wrong. For these protein structures. They'd used it to analyze various different protein structures over some years, and they had to retract 5 papers. And that must have had an enormously terrible effect on all the people in the group, the reputations of the people in the group. It's just a nightmare. This one, I don't think any researchers necessarily did anything wrong, made any mistakes in this one. This one is a piece of software called FreeSurfer, which is another kind of bio piece of software. When people updated from FreeSurfer 4 to 5 on a Mac running particular versions of OS 10, they found that the results changed, like 9% different answers from upgrading the version. This is very significant. Which one's the right answer? That's always the question at this point. I've got 2 pieces of software, it's 2 different versions of the same piece, same thing, giving different results. Which one do you trust? The conclusion on my paragraph on the left there, which is a extract from the paper, it's concluded that formal assessment of the accuracy of FreeSurfer is desirable. Well, I think I would go along with that. There have been various different examples of software working on one platform, and when you put it on another platform, giving a different answer. I worked with some researchers on an HPC cluster, and when the Intel compiler was upgraded, their own software started giving a different answer. I won't tell you which cluster it was or who they were, because I don't think their answer was a good thing, which is they said, can you downgrade it again? We preferred the old answers. This one is the most high profile example of such things that I can find. You may or may not have been around in 1999 when Mars sent its Mars Climate Orbiter, when NASA sent its Mars Climate Orbiter from Earth to Mars, spent 10 months or something traveling there, got there. Its job was now to put the spacecraft down onto the planet's surface. They started it, they thought it was all going to be fine, they lost contact. The link I've got at the top there is a long report from NASA a couple of years later, having done an exhaustive study of what went wrong. The answer was one team used feet and inches, well, pound seconds, imperial units, and one team used metric Newton seconds. And they hadn't talked with each other to the extent of saying, what units are we going to use for this? And so instead of being 140 kilometers above the surface when it was meant to be in orbit, it got down to 57 kilometers and disintegrated in the atmosphere. I said it was going to go down to the surface before. I was wrong about that. They were trying to put it into an orbit to analyze the climate. But the team who had designed one of the functions and the team who used that function didn't agree what units it was meant to be, so they sent it too low and it broke up. What should I do next? Some of you may now be thinking, goodness, okay, it's very easy to get this wrong and have wrong results and have to retract all my papers and so on. Well, I hope not. It's pretty rare when it happens, but it can happen. So what I suggest you do next is listen to Simon's talk, where he is going to answer all of the questions about what should be in your toolbox to do this stuff right. I may have set him up to a bit of a hard task there, but I went first, so I can.
Are there any questions for Ed? We have a few minutes. Are there...
Coding, what should be in your toolbox? Important. So Jeremy's introduced, open coding. Well, open everything Jeremy's introduced, but specifically open coding is where the bit I'm going to pick up on here a little bit. Ed's given us some motivation for why we want good coding and why we might want to know what's working, etc. But the question is, how do we go about this? What skills and tools do I need to be available to me? And as I've already sort of said, and already in the answer about what software language or something like that, I'm not going to. There's only a couple of places where I'm going to name specific things. I'm going to sort of name families and areas that you want, because there is lots of choice out there, and for most of them, I can't say that there's definitely one right answer. Most of them, there are options, and it's you want something that does this type of job, but there are options and you may pick different ones. Also, something else I'd sort of mention here is I'm going to be talking about coding, and we've been talking about coding, but actually a lot of what I'm talking about, or what you've talked about, are also there that, how do you manage your data? That's a very important bit is there. If you're doing lab-based experiments or out in the field experiments, how do you manage those? And some of the same ideas and concepts are also there. You need to have trust, and you need to have knowledge that the right thing is there. So while I'm not talking about those, there's very similar ideas coming up and concepts. First one I'm going to mention is version control. This is sort of my starting point, as the one I always throw in is track changes to your code. Know what you want to be able to know how you've changed it over time, or how it's been changed over time. Also allows you to tag releases of a code. If I picked up a publication you've got from, say, last year and go, where's the code for that? Can you show me, can you show me the code that you used to put, for the experiments in that paper, for the analysis in that paper? Could you do it? And a lot of what these type of things and what I'm talking about is, I know the answer for that for me is no. If you could go and pick one of my papers from about 15 years ago and the code isn't still available, I couldn't tell you which version it was used. And I now look back and go, well, actually, maybe I should have done something about that. But which is why I'm now telling other people, learn from mistakes that we've talked about, start well now. There. Probably the only area I'll mention about specific products is GitHub and GitLab. Very good at places to host your software repository, allow public access, allow you to publish your code. We may talk about publishing code as sort of, the positive, making it open, but also what we're seeing from research councils and publishers for publishing your paper is they want the code to be available. They think that the code should be available, and so you're going to be making it available. So if you start with it and start with it open, there. The other advantage, the bits I quite like about GitHub and GitLab is just the project management tool sort of side of it, of allowing you to plan and think about what you've done, and also well, I'll talk about documentation in a few minutes. Testing. This is the, Ed mentioned about the different results from FreeSurfer. How do you know your code is working correctly? What is working correctly? Did your latest change break it? Do you know? Would you know how to tell? There are also, what does your code do if it gets bad input? For those taking data from sources, at some point you will get bad data going into your code. If your code just keeps going and just replaces it by a default value, you might get a sensible looking answer out the end, but not know that something went wrong in the middle. There's also then sort of linting and formatting checks, which I've put under the testing. what I mentioned out there is when you are looking at lots of code, having very standardly formatted code helps other people to look at it. Which brings us to code review. Have somebody else look at your code, you know. It is scary the first time you have to hand over your code to somebody else to have a look at. It's like, you know, you will be worried, but you will write better code because of it. Can they understand what you've done? Do they think it does what you think it does? That's always a really good question to ask. They've probably, you know, somebody else may have suggestions for an alternative or better methods you can use or different ways you could have done it. And also, I talk about code review, something code reviewing your code. Actually, you code reviewing somebody else's code. One of the most helpful things I've found to writing better code myself is to review other people's code, because invariably what you do is you'll be looking at somebody else's code and go, well, why have they done this? Why have they done that? And then you'll go back to your own code and go, oh, I do exactly the same thing. No, let's do that differently. You know, I'm going to explain it better. I'm going to write this in a better way there. Documentation. This is partly for other people, but it's also partly for yourself. I talked about going back to that code for published in the past. Well, if you go back to your own code in 6 months, will you still be able to know what it does? Is it documented? Can you follow why you did something? There's also documentation that for when you're handing your code over to other people to use, you know, is there the right amount of documentation so the other person won't just spend hours trying to work out how to use the code or what input they need to do. It's all this, you know, aid the use of the code, aid the understanding, particularly with the open coding idea of if other people use it, they need to know how to use it. It's not just that it's available, they've got to work out how to, you know, you've got to know how to use it. So samples of, well, this is the type of input you need to do, and this is how you lay it out, and this is what you do, and this is the type of answer you should get, which brings you back to the testing of knowing how do you know it's giving you the right answer. And development environments, I strongly recommend using one of these. They're a very, very useful method. Those that say programming R are probably very familiar with RStudio, which is a very good example. Just this environment that will some natural formatting of the code to certain standards, but also presentation and functions and moving around, just better to use than a plain text editor. It's not always possible to use, but they are very, very. They've often also got the ability to sort of step through functions and debug your code as you're going along. So I've sort of mentioned Toolbox and different tools, skills. More have been mentioned in the chat as we've talked for the last about 40 minutes. There are plenty of other things that could be mentioned. You know, 50 is never enough time to mention everything. And each of the items I've mentioned there, we could spend hours and hours discussing. And as with any toolbox, you know, if I'm doing repairs on my house, I'm not going to get all the tools out of the toolbox every single time. It's going to be, I'm going to need this part, these tools today, but I might need, you know, a different set of tools tomorrow. And that goes back to sort of Ed's comment of understanding the scale of the job you're doing and what needs to be done. So you might not always need all of them, but you know, you've got to have some tools there that you can pick up and use. That's where I finish.
That's brilliant. Thank you so much indeed, Simon. Thank you everyone for attending.